Okay, hello everyone. In a new video. In this one we are going to solve an exercise related to optics in the chapters of lenses and formation of images. This exercise was a previous one in the Brevet exams in 2010, first session, first exercise. So the title of this exercise is focal length of a converging lens. Consider a converging lens L of focal length f. In order to determine the value of f, we place an object AB in front of L perpendicularly at A to the optical axis of L at a distance p from L. So here P represents the distance between the object AB and the lens L, which is the distance object lens. On the other side of L, we place a screen E parallel to AB at a distance P prime from L. And P prime represents the distance between the lens and the screen. We adjust the values of P and P prime in such a way that the image A prime B prime of AB is formed sharply on E and is equal to AB. So A prime B prime is equal to AB. Notice that here, because the image is being formed sharply on E, so the distance P prime now represents the distance between the image and the lens. Okay, moreover, here they told me that the image is formed sharply on E, okay, and we have that the size of the image is equal to the size of the object. So number one, they are telling me that the image A prime B prime is real. Why? Notice that till this moment they didn't mention anything about this document, so I'm not allowed to use it. Then all of my answers must be restricted to the given text or to the previous part. So we need to justify why that the image is real. Here they are telling me that it's formed sharply on E, and we know that only a real image can be collected on the screen. Then let's say since it's collected on the screen, in this case, then the image A prime B prime is real. And now they are telling me number 2 that the image A prime B prime is inverted. Why? Okay, we have already justified why that the image is real, and we know that a real image is inverted with respect to the object. Then let's say since it's real, then the image A prime B prime is inverted with respect to the object AB. And now in number 3 they are telling me, knowing that P is equal to 60 centimeters, show that F is equal to 30 centimeters. Then in other words, we need to calculate the focal length, because here F represents the focal length of the used lens, which is a converging lens. Okay, I repeat that yet till this moment they didn't mention this document, so we are not allowed to use it in order to calculate the focal length. Then we cannot calculate the focal length graphically, so we should search for another method. Notice that here in the same part they are telling me, knowing that P is equal to 60 centimeter, which means that we need to use this value in order to calculate F. Moreover, in the given they told me that A prime B prime is equal to AB. Then the size of the image is equal to the size of the object. So since A prime B prime is equal to AB, we know that whenever the image and the object are equal in size, then we have the following relation between P and F, which is given by that P is equal to the double of the focal length. So P is equal to 2F. Now we know the value of P to be 60 centimeters. We can deduce the value of F, because if we divide both sides by 2, then we will get that the focal length is equal to P divided by 2, and the value of P is given by 60. So the value of f in this case will be 30. Since p is in centimeters, then the value of f will be in centimeters. So the focal length is equal to 30 centimeters. Always all quantities in physics must have unit. Finally, it's a good habit to write our final answer in a box to make the task easier for the corrector to notice our correct answer. Here the focal length is positive, which verifies that the used lens is a converging lens, because we know that for a converging lens the focal length is positive. Now in number 4 they are telling me the figure below. They mentioned the figure, so now I can use it. Represents L, its optical axis, its optical center O, A, B, A prime, B prime, and E. Okay, for part A, they are telling me reproduce this figure on the graph paper using the same scale. Here the direction of propagation of light is not indicated, and the direction of the positive x-axis is not indicated as well, so we will take it as a default from left to right. And whenever we need to redraw, we always start by drawing the optical axis at the center, having the same direction of propagation of light, which is from left to right. So this is x prime and this is x. Then we place the lens L perpendicular to the optical axis at the center. This is the lens L, and the intersection between the optical axis and the lens L is the optical center O. Now the point A is located on the optical axis in front of the lens by 1, 2, 3, 4, 5, 6 divisions. Then 1, 2, 3, 4, 5, 6. This is the position of the point A. And the point B is located 2 divisions above A. A hat is found on B. This is the point B. And AB is the object. Now the point A prime is located on the optical axis behind the lens by 1, 2, 3, 4, 5, 6 divisions. So 1, 2, 3, 4, 5, 6. This is the point A prime. And the screen is perpendicular to the optical axis. At A prime. So this is the screen E. Now the point B prime is located 2 divisions below A prime on the screen E. So this is the point B prime. A hat is found on B prime, and now let's trace the image A prime, B prime. And the scale along the x-axis is given by 10 centimeters. So this is it for part A. Now in part B they are telling me the points B, B prime and O are on the same straight line Y. Okay, so if you connect these 3 points, so what does BO represent? BO is an incident ray, and OB prime is its emergent ray. As we can notice that these 3 points belong to the same straight line, because an incident ray issued from B, passing through the optical center, emerges without deviation. For this reason, then the points B, B prime and O are on the same straight line. Okay. Now in 5 part A, they are telling me trace on the drawing the path of the luminous ray issued from B and parallel to the optical axis. Here they told me trace, so no need to justify the path of an incident luminous ray issued from B. So this is issued from B and parallel to the optical axis. We know that always an incident parallel ray is related to the image focus, but here in this case we don't know the position of the image focus. However, we know the position of the image B prime, which is the image of the point object B. Therefore, this ray will emerge going to B prime. And we don't forget arrows on light rays that indicate the direction of propagation of light. Then done for 5 part A. Now in part B, they are telling me that the emergent ray corresponding to this incident ray meets the optical axis at a particular point H that's found at a distance d from L. D is the focal length of Ly. So the emergent ray, which emergent ray? This is the emergent ray. Meets the optical axis at a particular point H that's found at a distance d from L. So the meeting point between the emergent ray and the optical axis represents, or it's given by the point H that's found at a distance d from L. So this is the point H and this is the length L. Therefore, this is the distance d. They are telling me that d is the focal length of L. Why? So we are in part B. So the focal length is the distance from the optical center to the image focus. In order for D to be the focal length, first we must justify that H is the image focus. And here in this case, H is the image focus because an incident ray issued from B parallel to the optical axis passes through the image focus. So let's justify that H is the image focus. Then the image focus H is the intersection of the emergent ray of the optical axis. Because of this, now the distance t, which is the distance between the lens and the image focus, which is the same distance from the optical center to the image focus, represents the focal length. Then d, then the distance d represents the focal length. And now in part C, they are telling me find f graphically. So also the focal length is denoted by f. Then biographically means referring to its definition, which is given by the focal length is the distance from the optical center to the image focus. So f is equal to the distance from the optical center, which is the point O, to the image focus, which is denoted by h. And we don't forget the bar because this distance may be positive or negative. F is equal to OH bar. So notice that OH bar is in the same direction of the positive x-axis, which means it's positive. And now we count the number of divisions between O and H. We have 1, 2, 3. And we multiply by the scale along which we have counted the number of divisions, which is scale along the x-axis. This will give us 30. Since the scale is in centimeters, then the value of f will be in centimeters. So f is equal to 30 centimeters. And by this we have finished solving this exercise. Hope it was beneficial for you guys out there watching it, and see you soon in another one.